How many of you have been to the Forest View Planetarium in Forest View Middle School? Well, my name is Mr. Wallace, and if you have, I'm the person that works in the planetarium and gets to have a lot of fun with you guys when you come. Hopefully, this year, maybe by the end of the school year, things will get back to somewhat normal and you will be able to come with your class and visit the planetarium again. I sure hope so. It's a lot of fun seeing you all there. And hopefully, maybe by April or May, maybe field trips can start to happen. But if not this year, for sure next school year we'll get you back into the planetarium and have some fun. So what I'd like to do today is show you around a couple of programs that you can find on the internet that will help you become more knowledgeable of our night sky and be able to learn several things through them. And they are free. And if it's something that you might be interested in, just pay attention. I'm going to mention both of the programs that I'm going to be using today. But the main reason I am coming to you today is to teach you about what's happening in our night sky. There is something extraordinary that is occurring here in the next few weeks, and I don't want you to miss it. It's something that hasn't happened in my lifetime. It hasn't happened in your lifetime. It's been almost 800 years since this has occurred in our sky. Not even Galileo or our famous scientists like Einstein, none of them were able to witness what we are going to witness here later on this month here in December. So hopefully you can get outside in the next few days or in the next few weeks and enjoy this cosmic event that is absolutely extraordinary. I hope it's not cloudy on the big night. So let me describe to you what's going on. I'm going to show you, first of all, well, I tell you what, I'm going to go ahead and shrink down this recording of myself and put that over there in the corner. And then the first program that I would like to show you is a program called Stellarium. And I think you can kind of see it up here. It's Stellarium. Stellarium has been around quite a long time now. It is basically a planetarium in your computer. And so what you can do is download this onto your computer, set it to any date, set it to any location, and you can see what's going on in the sky. Even though you're not in a planetarium, at least you can see what's going on in the sky. And that's the first program that I'm going to use here. I have it set for today's date, which is the 9th of December. And I have it set for the evening of that, of the date. So obviously it's beyond December 9th for you right now, but hopefully not too far beyond December 9th. And what you are seeing here is a version of our sky set up here for where I live in Baxter. And I'm looking south. That's what this S stands for right here. And we can sort of swing around here if we wanted to and check out the horizon. The horizon is where the sky meets the ground out there. It's that imaginary line between the sky and the ground. But I have us facing south-southwest. And as you can tell right here, well, the time is 16:57. And so that's just short of 5 o'clock. And this time is 24-hour time. And it's not what we're used to seeing like on our digital clocks or whatever. But if we can take this digital time or this 24-hour time and take a look at, well, 16 is 4 hours beyond 12 and 12 p.m. And so that makes it 4 o'clock, and then it's 4:58 here. So it's just shy of 5 o'clock. And as you can see, the seconds are running forward. And as we look here, the sun is setting over here in our sky. Sunset is around 4:30 right now, and we're coming up on our shortest daylight day of the year. And that's very significant because the big night is happening on that shortest daylight day of the year. Now, what I have this set up for is tonight. And what I want you to take a look at is these two dots right here. Now those two dots are not stars. Let me go ahead a little bit further into time, and so they show up a little bit. You'll see some stars appearing up here and over in this direction. But right here, these are not stars at all. These are actually the two planets, Jupiter and Saturn. This one right here is Jupiter, and this one is Saturn. Now, Jupiter is much closer to us than Saturn is, but look how close they are in the sky. And if you get out in the next few days, and you'll see that difference, you'll see that distance basically close down on itself. And so I'm going to go ahead and skip us ahead days at a time. So instead of the 9th, I'm going to show you the 10th, the 11th, and as you can see, those two dots are coming much closer to each other. Okay, here we are in the 18th, 19th, 20th, and 21st. The big night, the 21st. Now on the 21st, that is our winter solstice. It's the day that we are maximum tilt away from the sun. But in this case, for this year, now this doesn't happen very often at all. In this case, Jupiter and Saturn are extremely close in our sky on the winter solstice. And it does happen about every 20 years or so. And I'll show you that in a little bit different model here coming up, why Jupiter catches up with Saturn. But this year it happens on our solstice. And that's just kind of coincidental. But it is kind of interesting that it's happening on the solstice where Jupiter and Saturn visually are coming the closest they are in the sky. And like I said, this hasn't happened for 800 years when they have become this close. Every 20 years, they get close to each other, but not anywhere near what they are going to be showing on the 21st. So I'm going to back this up a little bit. And as you can see, as we go back here in a few days, you can see that separation. Now, on the 21st, will you be able to see any distance at all between Jupiter and Saturn? And the answer is yes. Jupiter is much brighter. It's 12 times brighter than Saturn is. And so it will kind of dominate the two, but you should be able to see just a very slight gap between the two planets. Now, in a couple minutes, I'm going to talk to you about how far they actually are from each other, but I want to show you something that you can use to measure their distance in the sky. Now, what I have here is a way that we can measure degrees in the sky, kind of like you do using a protractor in math, measuring angles and so forth. Well, the degrees that we can measure the sky with, we can hold up our, let me see if I can get this. Okay, so if I hold up my fist at arm's length, that's about 10 degrees in the sky, 10 degrees in the sky from left to right. Now, that's going to obviously differ a little bit from person to person, but my arm is longer most likely than yours is. My fist is bigger than yours. But if you hold it out at arm's length, that's going to give us about the same measurement in the sky. And so you can see if you hold your fist up, it's about 10 degrees. Now, if you hold up 3 fingers, that's about 5 degrees. And if you hold up your pinky, that is about 1 degree. Now hold it, stretch it out at arm's length and kind of line that up with whatever you're looking at. Maybe close one eye, and that gives you about 1 degree of separation. Now the moon is about a half of your pinky at arm's length. If you could see a full moon, and you stick your pinky up there and put it in line and close one eye, that would be about half of your pinky. So it's about a half of a degree. Now, the reason I show you this is because I want you to understand just how close Jupiter and Saturn are going to appear in our sky. It's going to be about 1/10 of 1 degree. So if you take that pinky, there we go. If you take that pinky and you divide it into 10 pieces, if you line that up and you only take one little sliver of your pinky, that's about how close Jupiter and Saturn are going to be in our sky. That's going to be pretty extraordinary. Now, if you have a pair of binoculars, or better yet, if you have a telescope, that's the night to get them out. Because if you can look in that direction, you will see two planets in the same field of view in your binoculars or your telescope. If you use the binoculars or telescope, you'll also see some bright dots around Jupiter itself. Those are the moons of Jupiter. There are 4 that are very bright, and they're called the Galilean moons because Galileo is the person who discovered them and documented them. But you can see those. It's very cool. It's like a miniature solar system as the moons are going around that planet. Saturn also has many bright moons. So if you have a telescope on that night, you will be able to see both of those planets and some of their moons, depending on your magnification of your telescope. But you should be able to see both of them pretty clearly in one field of view. All right, so that's pretty cool. Now, let me close this off, and I want to show you another program, and I'm going to I'll do it in a different way here. I'm going to show you something called Solar System Scope. Now, I said it's a program, but it's actually a website, and you can see right here where it says solarsystemscope.com. It's totally free. And if you go to this website, you can click on this where it says Start the Solar System Model and jump right in. It is also a planetarium model as well. So you can take yourself down to the ground and look up into the sky. I am going to use it to show you the solar system and why Jupiter and Saturn appear so close to each other in our sky. Now, I'm not going to use the online version. I actually purchased the app. It's about $10. And so I'm going to disappear here from your screen, and I am going to open up the actual program called Solar System Scope, and you'll see that begin up here for me, and I will disappear because it goes over everything else. It's like a full screen mode. So here we go. And to begin with, it basically takes us right to the day and the time that we are currently experiencing. So here we go. Welcome to the solar system. And as this gets ready here, there we are. And there's all kinds of settings over here. And again, this is all just on the website. This is my desktop version, but you can do this on the internet without any cost at all. So there's different kinds of settings that you can choose. Lots of different options here on how you can view things, what you want to see on the screen and so forth. But I won't get into that much because I just want to show you. Here we have our largest, most massive thing in our solar system, of course, is our sun right in the middle. Our planets orbit kind of like going around a track. They all orbit in the same direction. Each one of the planets has its own orbit that is not a perfect circle. None of the orbit lines that you'll see here are perfect circles, but they're pretty close. And as we orbit around, we have one moon that we call the moon. Mercury, Venus have no moons, and Mars has 2 very small moons. But we have this one big moon that orbits around us about once a month. And I can just go ahead and grab onto Earth here and move it around. Isn't that cool? So as we move it around, you'll see the moon moving around, and we could count that, and it would be about 12 rotations or revolutions, that the moon heads around planet Earth like that over the course of one Earth orbit. And we have Mercury and Venus, which also move around the sun. And as we move Earth, you can see that Mercury moves much faster, Venus faster than Earth, but then Mars is slower. And it's kind of like being on a track at a track meet. If you have the inside lane, you have to go a shorter amount of time to get around the track, right? And so let me go back to today's date. I want to show you this phenomenon that we're seeing in the sky and why Jupiter and Saturn appear very close. Now, one thing you have to understand is that there is a light or a lit side of the Earth, and there is a dark side of the Earth. And when you're on this side, we call that day. When you're on that side, we call it night. That's pretty obvious. But why then do we see Jupiter and Saturn? Whoop, I messed up the time here. Let's go back here and go to actual time. I'm going to tilt our solar system, and you can see that when we are here on planet Earth and we're spinning around like we rotate our on the axis 24 hours every day, and as we spin around here to the dark side of the Earth, we can look out in this direction. Oh, I also have to tell you, this is not a scale model. So if Earth is that big, the sun would be not even on the screen so big. So we can shrink that down to actual size if you wanted to in settings, but I won't bother with that. Just know that this is not a real scale model. But if I tilt this just like this, and you can imagine that here we are if you can imagine us right over in this spot here on Earth, as we rotate around into darkness, we can look out into the sky and we can see Jupiter and Saturn almost in a straight line. Okay, so when you look at it like this, we can catch Jupiter here and Saturn right there. And if you can imagine that in the sky and go back to what I was showing you earlier, those two bright planets almost appear touching. But you also have to understand that Saturn is much further away than Jupiter. In fact, it's 407 million miles between Jupiter and Saturn, even on December 21st. That distance right here between Jupiter and Saturn is crazy big, okay? 407 million miles. But if we were to put time in motion here, let me go back out here just a little bit. As we put time in motion, you can see that Earth goes around in its orbit, but Mercury and Venus are faster. Mars and any of the other objects in our solar system continue to go around the sun as well, but in a much slower fashion. Now, they're actually moving pretty fast. I mean, even though it takes Jupiter much longer to get around the sun, Jupiter is actually cruising extremely fast. All right, it goes about 8 miles a second. And every Earth day, that's about 8 million miles. That's amazing how fast it is. It does take Saturn about 30 Earth years to go around the sun. And it takes Jupiter about 12 Earth years to get around the sun. So as things line up here in the sky, it takes Earth about 20 years to get in position to be able to see Saturn and Jupiter in the sky at the same time. So my advice to you is to get outside, go take a look at the night sky. Go take a look at where Jupiter and Saturn are on the current date that you see this, and maybe there will still be some separation here in the sky. Here we are on December 14th. But as we go past the 21st, the night of the big planetary conjunction, that's what this is called, because when two planets appear close to each other in the sky, that's called a conjunction. And on the 21st, that's the night that you will see them the closest. But beyond the 21st, you will also continue to see them close. And if it happens to be cloudy on the 21st, go out on the 22nd, you'll see them very close in the sky as well. But even as we go past Christmas and into the new year, we will continue to see Jupiter pretty close to Saturn in the sky. And then as it continues around, that's the way it is. It's past Saturn now, and it will take a very long time for it to come back around and catch up with it from our perspective. So that's called a planetary conjunction. I hope that you get out and enjoy this extremely rare event and have a lot of fun doing it. Get your family out there. Maybe you'll be on Christmas vacation by then. Take advantage of this very rare event. It's not going to happen again for another 60 years. Now, some of you will probably see that come around again, but it is not going to be as spectacular. It won't be as close. And this is your chance. So get out there, kids. Take a look at it. Hope you have a lot of fun. And I hope to see you back in the planetarium sometime during this school year.